Hello future beginners, subscribers, viewers, and students. Here is a video on general friction. These two problems were past problems given in the quiz, one of the in one of the sections I handled before. These are very simple. If you want comprehensive problems on friction, I want you to watch uploaded videos in my YouTube channel on friction. There are a lot of problems there, mostly challenging. Although the problems are arranged according to the degree of difficulty. So this problem here will serve as preliminary problems for you to understand and analyze problems involving friction. So three books rest on a table. Books A, B, and C weigh 2, 3, and 4 pounds respectively. Determine the horizontal force applied to book A that causes impending motion of any of the books to the right and determine which book moves. So this is the figure, and take note if you are going to consider this problem as a practical problem, actual problem, there are three possibilities. One, when we apply a force on book A, there may be a possibility that A remains at rest as well as B, and the entire unit of books will move to the right because C intends to move to the right. So, second possibility would be both A and B will move as a unit past C and C remains at rest. And lastly, it may only be A that will tend to move to the right and B and C will stay at rest in the position shown. So there are three possibilities, and let's investigate which of these three possibilities would be the real scenario. So if we consider the FBD of the entire system, that means if the entire unit move as a unit and C will be about to move, then this is the free body diagram. I'll call the force exerted by the hand as P in the figure. The total weight of the books would be 2 plus 3 plus 4, and that's 9 pounds as shown. And on the bottom, at this contact surface, we have normal and friction. Since motion is impending, that friction is maximum, mu s times n. Obviously, n is equal to the total weight of the books. So n is 9, and to solve for p, we sum up forces horizontal equals 0. So that means the general formula for p is mu sub s times n. So p equals mu sub s times n. Take note that in this configuration, n is equal to 9 pounds and mu sub s is equal to zero point 0.1. So p is zero point 0.1 of 9, and that is zero point 0.9 pound. For the second scenario, we have A and B will move as a unit. B tends to move to the right past C, and C will remain. And the total weight of the two books would be only 2 plus 3, and that is 5 pounds as shown. Then normal and maximum frictional resistance mu sub s times n. The normal in this situation here is equal to 5 pounds, obviously, and P is equal to mu s times n, where mu s this time is zero point 0.3. So zero point 0.3 of 5 is 1.5 pounds, so P is equal to 1.5 pounds. Then lastly, if only A will tend to move past both B and C, the FBD would look as shown. So we have P, and the weight is weight of A, which is just 2 pounds. And therefore, the normal reaction here at the contact surface between books A and B would also be 2 pounds. And since P is equal to mu s times N, P is equal to zero point 0.6 times normal, which is 2 pounds, and that is 1.2 pounds. Therefore, the final answer, P is equal to 0.9 pound, because at this value of P, C is about to move. And it will take 1.5 pounds, which is greater than zero point 0.9, and 1.2 pounds, which is also greater than zero point 0.9 for the other scenarios to impend. So the answer, P is zero point 0.9 pound, zero point 0.9 pounds, and book C is about to move for that case. So for this second problem, the coefficient of uh, static friction between the right bar and the surface at A is mu sub s equals zero point 0.6. Neglect the weights of the bars. If alpha is equal to 20 degrees, what is the magnitude of the friction force exerted at A? Then what is the largest angle alpha at which the system will remain stationary without slipping? So for the second part, it gives us the idea that this situation is we have impending motion, so that the maximum frictional resistance is equal to mu sub s times normal. So this is the situation. A is pinned, this is also pinned, and A, we have a surface here which is rough. So the free body diagram, we have X and Y components of the reactions at this pin here. Just call them X and Y respectively. Then at A, we have normal at A and friction at A. The frictional resistance is not necessarily maximum for this case. It depends on the situation. Let's solve for FA as if we have to apply principles of statics only, the free body diagram. If I call the length of each bar as L, then this vertical distance should be L cosine of alpha, and each of this horizontal projection of L would be L sine alpha, shown L sine alpha, so that for the free body diagram of the entire system, summation of moments about this left pin here equals 0 and counterclockwise positive, we have Na times quantity 2L sine alpha equals big F times L cosine alpha. Fa is not involved, its line of action passes through that pin there. So simplifying, after we cancel L, that means Na is cosine alpha divided by 2 quantity 2 sine alpha, and that is cosine over sine is cotangent, so that is F cotangent alpha over 2 Na. Then, considering the free body diagram of the right leg or right portion of the system, this is the FBD. We will call the X and Y components at the pin here as X1 and Y1 respectively. Then we sum up moments about that point equals 0. Then our equation would be, so remember this is L cosine of alpha. Our equation would be Na times L sine alpha equals Fa times L cosine of alpha. Canceling out L, that means Fa is equal to Na, or Na, Fa is Na tangent of alpha. Substituting now the value of Na from this equation here, so Fa is equal to F over 2 cotangent of alpha, which is Na, times tangent alpha. Since cotangent alpha, tangent alpha is 1, then Fa, the answer to the first question would be F over 2. Then for the second question, this is obviously impending motion situation. So we equate Fa max, which is equal to Fa f over 2 to mu sub s times NA, so that we can maximize or we can determine the value of alpha, largest value of alpha, for which is impending motion or impending slipping would occur at A. So substituting, this is f over 2, mu sub s is 0.6, and NA is equal to f cotangent alpha over 2. So f over 2 equals mu sub s times NA. So f over 2 equals 0.6 times f cotangent alpha over 2. We cancel out f over 2. So 1 equals zero point 0.6 cotangent of alpha, or 1 over cotangent alpha. Tangent alpha is zero point 0.6 over 1. So tangent alpha is zero point 0.6. From there, we can now compute alpha, and it is inverse tangent of zero point 0.6, and that is 30.96 degrees. So that's it for this video.